Hello friends, this video on hydrogen part 4 is brought to you by examfear.com. No more fear from exam. Now let's talk about the isotopes of hydrogen. So there are three isotopes of hydrogen, and before we study isotopes, let me tell you the definition of isotopes. Once again, you have learned this in your class 10. So isotopes are nothing but they have same atomic number but different atomic mass, and that's why they have similar properties actually. So for hydrogen there are three isotopes. This is protium, this is deuterium, and this is tritium. So for protium, if you see, there is one proton and one electron. This is electron. This guy is also electron. So for protium, there is one proton, one electron. For deuterium, there is one neutron, one proton, one electron. For tritium, there are two neutrons. It's very heavy, and that's why it is unstable and it is radioactive. We'll study this later. Little heavy, this is unstable, so it is radioactive. This is also heavy. This is called heavy hydrogen. Why? Because it has more neutrons, so more atomic weight. So the most abundant is this guy, protium. It has one proton, one electron. The next is the heavy hydrogen or deuterium. It has one neutron, one proton, one electron. And then we have this tritium. It has two neutron, one proton, and one electron. So the proton and electron count is same, only the neutron count is increasing. Right? So we have protium denoted by H, 1. We have deuterium, also called heavy hydrogen, denoted by D. This is denoted by D. This is by H. And then we have tritium. It's very rare, denoted by T. So I have H, D, and T. It's very rare, and it is formed in the upper atmosphere by the nuclear reaction, and it is radioactive in nature. We'll study this later. If you see the property, if you compare the property, hydrogen, that the protium, don't confuse it like we write here, this is protium and this is deuterium, this is D, this is H, this is T, right? So the hydrogen, they have the most abundant, 99.9% is hydrogen, in fact 99.99% is my protium. Then you have very less occurrence of deuterium, and this is, you see, it's a very rare occurrence of tritium. It's this is radioactive. If you talk about the atomic mass, this is almost atomic mass of 1, this is almost atomic mass of 2, and this is 3, because you're adding one neutron each. Talk about the melting point, it also increased. This is 13.96 Kelvin. This is 18.7 here, this is 20.62. If you talk about the boiling point, that's also increased, right? Because we have more neutrons there. Talk about density, also it increased because it is more heavy, right? If you go this side, the density, boiling point, and melting point increases. But if you see the abundance, this guy is most abundant in Earth. We're talking about the Earth. We are not talking about universe now. And if you talk about the physical and chemical properties, since the isotopes have same electronic configuration, and we explained this in the atom chapter, that the chemical property depends on the electronic configuration. They have same number of electrons, right? So they have same electronic configuration. So they have almost similar chemical properties, but the rate of reaction will differ. Correct? So, and the physical properties, if you talk about the melting and the boiling point, they differ slightly because there is a huge mass difference, right? If you see, this is atomic mass 1, this is almost 2, this is 3. It's almost double. It's almost double again, right? So the difference is huge. If you talk about other elements where we have one extra protons or neutrons, for example, one has atomic mass, let's suppose 80. So if you add extra neutron, it becomes 81, this becomes 82. Extra neutrons, I'm adding it, right, to give different isotopes. So you see the relative atomic mass difference is less, right? It's only, it is, if we talk about percent, it is not even 1% difference, right? But if we talk about this is 50% or 100% actually. 1 became 2. Here also 2 to 3, it's almost 60%. So the difference is huge when you're talking percentage, and that's why the physical properties differ in this case of isotope. But in other isotopes, if you see, the physical property doesn't differ much, because if you add one neutrons to create new isotope, the atomic mass difference, the difference is still 1, but the percentage wise, if you see, it's very less. It's maybe 1.5% here, yeah, or 1.25 actually to be specific, and here it is almost 100% and 60%. So there's a huge difference in the physical property. Okay, so thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.